Well, hello everyone. Today I'll be going through the Year 12 Math Methods worksheet 16, so the final worksheet before the holiday. And this one is pretty tricky, so let's have a look at it. The first question asks us to sketch this hyperbola. So the 2 and -1 here should tell us the equation of the asymptote, right? So y is 2 and x equals to 1. And then after we graph these two asymptotes, I like to work out the two intercepts and work out some random points on this graph so I can know I can get my shape right. So I work out these two, which is our intersect points, and these are just some random points I worked out just to ensure the shape is right. So after I work those out, we connect the points and then there's a hyperbola, and that question is done. Question B, we need to find the area includes the graph between 2 and 4, which is basically from here to here, this area here. So this is our area here, and we just do the integral, and 2x becomes, so 2 integrated becomes 2x, and 3 divided by x minus 1 integrated becomes 3 log e of x minus 1, and then we sub in 2 and 4 into it, and the final answer is 4 plus 3 log e 3. Don't forget the unit squared at the end. Question 2 is a probability question. The first question asks that what is the probability that the number of tag sheep on a select day is 0. So in that, it's 4. The sheeps are tagged 4 times on each day, and each time's probability of a sheep being untagged is 2 on 3. Therefore, 4 times each day is just 2 on 3 to the power of 4, which is 16 on 81. So the next question is probably that at least one sheep is tagged. So notice that that's just 1 minus probability from before, because if we know that if we minus probability that no tagged sheep is selected, then well, we're just left with either 1, 2, 3, or 4 tag sheep is selected. That's our probability here. And the final one, we know that each day the probability of a sheep being tagged is each day being no tag sheep selected is 16 or 81. So 6 days is just that to the power of 6 basically. Okay, so question 3. So after this is all the questions after this is pretty tricky. So the first question is that show by differentiation that this is the antiderivative of this. So we basically have to derive this and see if we get something like that, basically. So we derive this, we use the product rule. The first part goes into this one, the second part goes into that, we add them together, simplify a little bit, and then take the x k minus 1 on k out. And because there's a k, so I guess I can, for this step, this k here will cancel out with this k here because this plus 1 and minus 1 cancels out each other. And that leaves us with our final answer here. Probability of x is bigger than 1 on e is just the integral of this. So notice how we, first of all, this -4 thing here we take out. So we're left with x log e x. And by looking at this, right, k is just equal to 2 because 2 minus 1 is just 1. So x power 1 is just x. So, and that's why we know the integral is just this. And we just replace every single k with 2. And we get something like this. So this is, I guess, I'm just going to draw a line here. My working out has exceeded that question. But yeah, so we know that it's -4 to the x squared on 4 times 2 log e x minus 1. So we just replace every single k with 2. And the terminal is 1 on e to 1. And we're subbing all the values and we end up with 1 minus 3 squared. The next question is pretty tricky. It's asking if the median of x is greater than or less than 1 on e, given that e is bigger than that. So if e is bigger than 5, so first of all, we should notice that this area before, so this area here, we got 1 minus 3 on e squared, right? That implies that this area here must be 3 on e squared then. So if we know that e is bigger than 5 on 2, then 3 on e squared must be less than 12 on 25. So notice how that's the denominator. So that is that. First of all, we know that the median must be in the other portion of the area, right? And because we know that because 1 minus 3 on e squared, and that is bigger than 12 on 25, basically. And we know that e is bigger than 2 on 5. So 1 on e implies that 1 on e is, less than 2 on 5, right? So if 12 on 25 is bigger than 2 on 5, then that just implies that 12 on 25 is also bigger than 1 on e. And if 12 on 25 is bigger than 1 on E, then we know because then 1 minus 3 on E squared must be bigger than 12 on 25. And because of that, we know the median lies in this area here. So that means it must be bigger than 1 on E, because 12 on 25 is bigger than 1 on E. So it is a pretty tricky question here. So for question 4, we have these two graphs here. First of all, the very tricky part for this is asking for the entire area. So it's a total average shaded region as A from 0 to pi. So a very easy mistake here, just put A as 2, right? Because we only consider from 0 to pi. But it's asking for the entire area. That's when we need to double it. So it's 2 times 2, which is 4. The next question asks us to draw this graph here. So the period is 2 pi on 3. The amplitude is 1 on 3. So we just draw that in, right? So because we know that this part here is 2 pi on 3, 4 pi on 3, and 2 pi here. And all we're left is just draw the normal sine graph. And this is for this question here. The next question is relatively easy as well. F of x to h of x. H of x is this, f of x is this. First of all, we need to dilate it by 1 on 6, because 2 times 1 on 6 is 1 on 3 in the direction of so from the x-axis. And second of all, it's the tricky part. Remember how dilation by the y-axis is reversed. So if we become x to 3x, then it must be a dilation factor of 1 on 3 from the y-axis. Okay, so the last two questions are very tough. First of all, it's asking that it gives us two functions here, k of x and q of x. And we're asking for the area between x's from 0 to 2 pi, basically. So the trickiest part here is that, well, this is, first of all, this will give us the area of top function minus bottom function. So that's all good here. The tricky part is that the integral is 2 times 0 to pi, not 0 to 2 pi. And the reason because of that is if we look at this graph here, right? If we do 0 to 2 pi, then notice how one area is positive and one area is negative, so they will cancel out each other. They will cancel each other out. So it's, not accurate here, see? But if we 0 to 2 pi, then this area here, this area here will cancel with this area here, giving us 0. And that's why we have to work out the area from 0 to pi and just double it. So that's why we have to use this integral here. After we do this integral, we get this thing here. And we know that if n is even, cosine of n pi is equal to 1, right? So 2 times 1 minus 1 is just 0. So the answer here is 4n plus 0 on n squared. And by the same logic, if n is odd, cosine of n pi is -1, then we start the -1 in here, we just get 4n minus 4 on n squared. So theoretically, the best way to write this should be 4n plus -4 on n squared. I think that's the form that the question wants us to write it in. So yeah, that's, I guess, all the answers. And yeah, if there's any other questions, please let me know. Other than that, hope you guys have a good holiday, and I'll see you next term.